Hello friends, welcome to EK lectures. In this lecture we will be discussing about the numerical analysis part where we will be discussing about different numerical methods to solve for the given function as well as find the roots of the functions. The Newton-Raphson method is what we are going to see in the numerical analysis. Newton-Raphson method. Now this is also called iteration method. Now why it is used? It is used to find one root of a polynomial given by f of x equal to 0. Now the formula that we have to use is xn plus 1 equal to xn minus f of x divided by f dash of x, where xn plus 1 is the n plus 1th value of x, that is the iteration value of x. This is the nth value, that is the present value. F dash of x as the first derivative of the function f of x, first derivative. Now you can write here xn and n, that is f of x at x equal to xn. This is also same, the f dash of x should be f dash of x is nothing but f dash of x at x equal to xn. This is the nth value or the present value. N plus 1 is the next value or n plus 1th value. We have a question to solve using a Newton-Raphson method. The function is given. We have to find out the roots of the function f of x. Now let's take find f of 0. So 0 minus 5 times 0 plus 3. So f of 0 is 3, and let us also find f dash of x. F dash of x is 3x square minus 5. Now let's also find f of 1. F of 1 is 1 minus 5 times 1 plus 3, that's equal to minus 1. Now what is the formula? Y or the roots xn plus 1 equal to xn minus f of xn divided by f dash of xn. Okay, now we already got the first root. We have taken the first guess. Guess means just any random value. First guess is equal to 1, that is this becomes xn now. Okay, now xn 1 is 1 we already have got. Now we need to find x2. This is equal to x1, so x2 will be equal to x1 minus f of x1 divided by f dash of x1. So x1 we already got 1 minus f of x1. F of x1 means f of 1, that is minus 1 divided by f dash of x1. F dash of x is 3x square minus 5. 5 substitute for x equal to 1. 3 times 1, that is 1. 3 minus 5, that is minus 2. So 1 minus 1 by 2, that's equal to 1 by 2. Now we got x2, that means second value. Now x3 equal to x2 minus f of x2 divided by f dash of x2. So that's equal to x2 is 1 by 2 minus f of half. F of half means we have to substitute for x equal to half in this function. So f of half means half cube minus 5 times half plus 3. So that's equal to 1 by 8 minus 5 by 2 plus 3. What we can do here, okay, keep it like that. Then we have f dash of 1 by 2, because in the denominator we need f dash of x2. So f dash of 1 by 2 means 3 times 1 by 2 squared minus 5. So 1 by 2 minus the numerator we have 1 by 8 plus minus 5 by 2 plus 3 divided by 3 by 4 minus 5. So this accounts for 1 by 2 plus 1 by 2 plus 5 by 34, which is equal to 22 divided by 34, or 11 by 17. So this is the approximate value of x, function of x, such that the f of x, no, this is roots, means this f of x should be equated to 0. Okay, when f of, you can substitute the value of x given here and you will get more near to 0. The next time if you find out x4, it will be giving you more closer value to what is it, 0. Question is, find the roots of the function f of x equal to 3x cube minus 4x minus 5 using the iterative Newton-Raphson method. The initial guess is given, that means this is x naught is given as 2, and we are asked to find out the next value, that is we need to find x1. So formula xn is equal to, sorry, xn plus 1 equal to xn minus f of xn divided by f dash of xn. So xn is given to be 2. Let's write down what are the functions. F of x is equal to 3x cube minus 4x minus 5. So f of 2 will be equal to 3x cube, 8 times 3, that is 24. 24 minus 8 minus 5, 13, that is equal to 11. Now f dash of x is equal to 9x square minus 4. So at f dash of 2 is 36 minus 4, 32. So now xn is 2 minus f of xn is 11 by 32. So that's equal to 64 minus 11 by 32. That's 53 by 32. So this is equal to x1. Newton's interpolation formula. Newton's interpolation formula is used to find the function f of x, that's equal to y, from some set of x and y values. Some x and y values will be given, and from that we are going to find the general formula for y equal to f of x. So y is equal to f of x is equal to y naught plus u into delta y plus u into u minus 1 by 2 factorial into delta square y plus u into u minus 1 into u minus 2 divided by 3 factorial into delta cube of y, etc. Now y naught is the first value of y, and u is u equal to x minus x naught by h, and h is the width of x values. Now here we have the x and the corresponding values of y here. So x naught, x1, x2, x3 are the values given for the x, and corresponding value for y are y naught, y1, y2, y3. Now we will find out the delta y. This is equal to y1 minus y naught. This is given by delta y naught, just a value given. Now this is equal to y2 minus y1, that's equal to delta y1, y3 minus y2 equal to delta y2. Now we have the second derivative, that is delta square y. It is given by delta y1 minus delta y naught, that's equal to delta square y naught. Here we have delta y2 minus delta y1 equal to delta square y1. That means this is this value is the difference between these two, and this particular value is the difference between these two values. Now we have the delta cube y, that's equal to delta square y1 minus delta square y naught. So now we got the values of delta y, delta square y, and delta cube of y, and you also have the value of u. Substituting all this value, you are going to arrive at y equal to f of x. Using Newton interpolation formula, find y of x at x equal to 1.5, that is function at 1.5. Now this is x, this is x naught, x1, x2, x3. Corresponding values of y, that is y naught, y1, y2 and y3. This is delta y here, this should be delta square y, delta cube y. Now the formula y is equal to y naught plus u into delta y plus u into u minus 1 times delta square y plus u into u minus 1, this is u minus 1 divided by 2 factorial, u minus 1 into u minus 2 divided by 3 factorial into delta cube y. Now what is u? U is equal to x minus x naught by h. Now x is what we need to find, x equal to 1.5. So 1.5 minus x naught is 1 divided by height is this width from x naught to x1. Okay, so width is 1, so that's equal to 0.5. So the u is 0.5. Now this is 7 minus 1, that is would be 6. Then 17 minus 7, 10. 31 minus 17, 14. 10 minus 6, that would be 4. 14 minus 10, that would be again 4. This is 0. So delta cube y, fourth term goes to 0. So that's equal to y naught is 1 plus u is 0.5 times delta y. Delta y is the first term here, 6 plus u is 0.5 into u minus 1 is minus 0.5 divided by 2 factorial into delta square y is again 4 here. Third term is 0, delta cube y, that's equal to 1 plus 0.5 times 6 is 3 minus 0.5 times minus 0.5 is minus 0.25 and minus 0.25 so that can be taken as 1 by 2, so minus 1 by 4, so that is minus 1 by 2. So 1 plus 3, 4, 4 minus half, 3.5. So the numerical integration. Now numerical integration is used to find the integral value of a definite integral. Now when we say definite integral, this will have the lower limit x naught to xn, that's equal to f of x into dx. Now the first method is the trapezoidal method, where the integration from x naught to xn f of x dx equal to, the formula is h divided by 2 into y naught plus yn plus 2 times the remaining y values or remaining terms. Now just for an example, let us take the values, that is x and y. Value starts from x naught, x1, x2, x3, x4 and x5. The corresponding values of y are y0, y1, y2, y3, y4 and y5. Okay, now according to the formula, we have h is equal to xn minus x naught divided by n, where n is number of spacing. Okay, now according to this the number of spacing is 1, 2, 3, 4 and 5. So the number of spacing equal to 5. Xn is the last value, x naught is the first value, divided by n is the spacing. So h is nothing but the width. Okay, now considering this as an example, we will write down the equation, or the assuming that y is what we need, that is the definite integral value. Y is equal to h, that is xn minus x naught divided by 2 into the n is 5, that is the number of spacing, times y naught is the first value and y5 is the last value, plus 2 times sum of the remaining terms. So here we need to rewrite this. This is sum of remaining terms. So what are the remaining terms here? Y naught is already used and y5, that is the last term. So remaining terms are y1 plus y2 plus y3 plus y4. So the integral value will yield from this particular equation. So this is the trapezoidal rule or trapezoidal method. So here we have the second rule, that is Simpson's 1/3 rule. This is also used for finding the definite integral. So this is also used to find out the definite integral value. Let's take for example integral x naught to xn f of x dx. So this, let it be equal to y. So the formula is h divided by 3 into y naught plus yn plus 2 into y even, that means sum of even terms, plus 4 into sum of odd terms. Okay, now y even means y2, y4, y6, etc. Y odd represent y1, y3, y5, etc. So excluding y0 and yn, the y even and y odd term should not contain first and the last term. For example, if we have this as x and the corresponding values of y, x0, x1, x2, x3, x4 and x5, and corresponding values of y are y0, y1, y2, y3, y4 and y5. Here you can write h by 3. Now h is, as we have mentioned earlier, h is equal to xn minus x naught by the number of spacing n. So n is spacing. Okay, so h by 3 into the y naught plus y5, that is the last term, plus 2 into even terms. So even terms are y2 and y4. So here let us write y2 plus y4 plus 4 times sum of the odd terms. Odd terms include y1, y3, and y5 is not included. Okay, so only two terms, y1 and y3. y5 is in the first term, so here you can write y0 plus y5, and if you want to write 1 into, you can write simply. So this is the formula for Simpson's 1/3 rule. So 1/3 rule, here you have h by 3 into y0 plus y5 plus 2 into y2 plus y4 plus 4 into y1 plus y3 according to this example. Simpson's 3 by 8 rule. This is the another numerical integration method for finding the definite integral. And the integral is x0 to xn f of x dx. Now the Simpson's 3 by 8 rule is equal to 3 by 8 times h, where h is equal to xn minus x0 divided by n, where n is the number of spacing between xn and x0. Now into y0 plus yn, this is plus 2 times y3n plus 3 times remaining y terms. Okay, now what is y3n? y3n is y3, y6, y9, etc. Okay, now for example, if we have x and the corresponding values of f of x, that is y, x1 sorry x0, x y1 y0, x1, y1, x2, y2, x3, y3, x4, y4, and x5, y5. Then according to the formula, we have 3 by 8 into h is x5 minus x0 divided by number of spacing. So spacing starts from x0, 1 2 3 4 5, so x5 minus x0 by 5 into y0 plus y5 plus 2 times y3n. So now 3n, one is y3, y6 is not available, so it will be y3 only, plus 3 times remaining terms. What are the remainings? y1, y2 and y4. So y1 plus y2 plus y4. So suppose if there is x6 and corresponding y6, then this term will not be included in y3. This will be considered as the last term only. Okay, this will, okay. So this is the Simpson's 3 by 8 rule, where h, as we already mentioned, xn minus x0 by n. So the formula goes like this: 3 by 8 times h into y0 plus yn plus 2 times y3n plus 3 times the remaining y terms. Here we have a question. Find the integral of the function f of x. X and y values for a few terms for x is given as follows, and we have to find the integral using the trapezoidal rule, Simpson rule, and Simpson 3/8 rule. Renji-Kutta method. Here we are asked to find the function dy by dx will be given, dy by dx, or f dash of x will be given, and we have to find f of x, which is equal to y at x equal to some a. So the question here is, we are given the function that is the first derivative of y with respect to x is x square minus 2x plus 1, with the initial condition is given, that is y of not equal to 1, and we need to approximate the value of the function y, that is f of x, at x equal to 0.2. Here x equal to a, and the step size is also given. Step size is h equal to 0.1. Now we need to apply the Renji-Kutta method. Now let us say we are applying the fourth order Renji-Kutta method. That means up to the order 4. Now dy by dx equal to x square minus 2x plus 1. Now y of naught, that means the initial condition is given as 1. Now here we have already chosen the height, that is the step size is 0.1, and we'll start with x naught and y naught. These are the two initial values that we have, and y naught is equal to y at x equal to 0, which is already given to be 1. Now we need to find and what about x naught? X naught is 0 and y naught equal to 1. Now we need to find out the constants, the values of k1, k2, k3 and k4 if you are going for fourth order. So k1, k2, k3 and k4, this is what we need to find. Now k1 is given by h, the height, times the function of x comma y, or xn comma yn. So that's equal to 0.1 into the function f of x. Now at x equal to we have already seen at x equal to x naught. Now that's equal to 0.1 into, what is the function? Function is x square minus 2x plus 1, that at x equal to 0. So 0.1 into first term becomes 0, minus second term again 0, plus 1. So that's equal to 0.1. Alright, now that's the k1, 0.1. Now k2 is equal to h times f of xn plus h by 2 plus, sorry, it's comma, it's a function of xn plus h by 2 y n plus k1 by 2. K stands for the value of y. Okay, now again h value is 0.1. It's a function of xn plus h by 2. So it's xn is 0, 0 plus h is 0.1 divided by 2, comma yn is y1, that is 1 plus k1 by 2 is 0.1 by 2. Okay, so that's equal to 0.1 into 0.1 by 2, 0.1 by 2 whole squared plus 2 into 0.1 by 2, that is 0 into minus, plus 1. So again this gives 0.1 into 0.05, 0.05, or we can write 0.01 square of 0.1 divided by 4 minus 0.1 plus 1. So that will be equal to 0. We have to subtract this 0.1 into, this is 1 minus 0.1 is 0.9, 0.01 divided by 4 is 775. So it would be 0.9775, that will be equal to 0.09775. So that is, this becomes k2. So we are more, it means that we are more earlier this was our k1 which is 0.1. now we became k2 which is more near to the original value. Okay, similarly we can find the values of k3 and k4, which is equal to, this is k3 and here we have k4, and substitute in the here. This is for the value of x, this is value of y, yn plus 1 equal to yn plus k1 plus 2 k2 plus 2 k3 plus k4 by 6. This is a weighted average of k values. So 1 plus 0.1 plus 2 times the value, this is k1, this is k2, here we have k3, and this is k4. So finally we will get the answer 1.095333. Okay, so this is the method for finding the function f at x equal to a when first differential equation is given, first order differential. So f dash of x is given.